that's great. Let's see if any other students are waiting. Okay, so let's start with the chapter 12. This is the shortest chapter of out of all the chapters. So let's look at their questions. Let me open my Leonardo as well, so because I might need to type in here as well. Okay, start assignment now. So regarding the first question, so during the first 13 weeks of the television series, so this is actually a goodness of fit test, right? So if we open our like goodness of fit handout to chapter 12, okay. So first 13 weeks of television series, Saturday evening, 8 to 9 p.m. Audience proportions were recorded as ABC 29%, CBS 27%, NBC 24%, and Independence 20%. Okay, so the null would be, in that case, we can write the probability distribution like so on and so forth. So let me finish reading the question. So a sample of 300 homes 2 weeks after the Saturday night schedule yielded the following viewing audience data. Okay, so 93 homes watched ABC out of 300. 63 watched CBS, and NBC 85 homes, and Independence 59 homes. So that's the original one, but proportion was 29%. Okay, so 93 by 300 would be 0.31. In actual, it's different. Okay, so first let's write they said find the test statistic and p-value. So what we have to do is, first we have to formulate the null and alternative hypothesis, right? So null would be proportion of ABC. Okay, what is the proportion of ABC? 29%. So the proportion of ABC should be 0.29, comma, proportion of what's the other one? CBS, right? CBS should be 0.27, NBC is 0.24, right? And independent is 20%, so 0.20. So proportion of independent 0.20. So we are using this format. So that's the null, right? And what would be the alternate? Alternate would be they are not. So proportions are not then I just rewrite PABC is 0.29. Okay, PCBS is 0.27, PNBC, proportion of NBC is 0.24, sorry, 0.24, and proportion of independent is not equal to 0.220, right? So first we formulated the null and alternative hypothesis. We need to find the expected frequency, right? If you recall, so what's the formula for expected frequency? it's number of sample times pi, right? So this is the expected frequency. So what is the expected frequency for E1, which is of ABC basically, right? So what's the total sample size? 300 times what would be the 0.29, right? So what is it? It's 87, right? Okay. What about E2? 300 times the second one, right? Can anyone speak it out loud? Yeah. Oh, hi. Salam, yes. What's E2? The expected 81, right? Yes. So it's 81. E3 is actually, let me use a blue color. I think it's better for the eyes. 300 times 0.24, right? So 0.24, it's 72, and E4 is 300 times 0.20, so that's 60. So these are the expected frequency, right? But what did we get in the original one? We got 93, we got 63, 85, and 59. So originally we have different frequencies. So we actually, F1 is 93, 63, 85, 59. 93, F2 is 63, F3 is 85, and F4 was, what's the F4? 59.
Professor, for F3 you wrote 84, but it's supposed to be 85.
85, oh, thank you. That's good. Good, you guys are keeping a good eye. Yeah. So then we have to find the F minus E square divided by E, right? For each of the cases. So it's a chi-square test, goodness of fit. So the formula is F minus E square over E, right? The general formula, Fi, Ei, Ei, and then there is a summation sign, right? So for the first one, it's F1 minus E1 divided by E1, and you have to square the first one. Similarly, F2 minus E2 square divided by E2 till E4 we have to do, right? So F3 minus E3 square by E3 plus F4 minus E4 divided by E4 and this one square. So only the numerator is squared in this case. So let's do that calculation here. So first one is 93 minus 87, right, square, and then EI, first one is 87, right? Then second one is 81 minus 63 square divided by 63, and the third one, let's use a different color. Third one is what? 72 and 85. So 85 minus 72 square over 72, right? And the last one is 59, and where is the other E4 is 60. So 59 minus 60 square over 60. Okay, so you need to use your calculator in this case. So 6 square by 87. 18 square over 63 plus 7 square over 72. Negative 1, when you square it, it's still positive, right? So it's 1 square over 60. So let's see how much we got. So 6 square over 87 plus 18 square over 63, 7 square over 72 plus 1 over square over 60. So we got total chi-square is 6.2539. I just kept 4 decimal places. Let me see how many decimal they want. This is the chi-square value. So the test statistic 2 decimals, so 6.25. 6.25. What would be the p-value? P-value, we can use Excel, right, to calculate. So let me open the Excel sheet. So p-value chi-square test. So I have given you guys the formulas. So it's an upper tail chi-square test. So we use this formula, right? Let the Excel load. What's happening? Okay, new worksheet. So chi-square dot dist dot rt. What's our test statistic? 6.2539. 6.2539. What would be the degree of freedom in this case? If you review your notes, degree of freedom is the number of categories k minus 1, right? So let me highlight this. K, how many categories are there in this case? 1, 2, 3, 4. 4 categories. So 4 minus 1. So the degree of freedom should be what? 4 minus 1, 3. Yes. That's good. So the degree of freedom is 3. So we got the chi-square test statistic and degree of freedom. So p-value is 0.0989. So it's less than 0.1. Anyway, let's go here. So somewhere between here, right? Okay. So conclusion, can we reject? We cannot reject because our p-value is bigger than the significance level. So not significant change. Let's see this one. 6.25. What's wrong with this? Should be this one, or perhaps I have made any mistakes here copying the thing. 93 minus 87, that's
I followed along with exactly how you did it with my own numbers, and I got the statistic right. So there's probably just a really simple calculation error somewhere in there.
Yeah, so it would be probably a simple one.
But you definitely did it right because I did it the same way and it came out correct.
Okay, 93, 63, 85, 59. Let me see. 93, 60. Oh, you know where I made the mistake? I think 93, 63, 85, 85, 59. I'm trying to see where I made the mistake. 81, 87, 300 times 0.2472. Yeah, I mean, here instead of like this, the F1 should be first and then 81 should be second, but it doesn't matter because there's a negative sign, right? It still should be positive here. 85 and then the 72 is here. F4 is 59, right? 59.
So, Professor,
Yeah.
could you explain the last, or on the other page, on Mindtap?
Okay.
So, why would it be there is no significant change in the viewing?
Okay, so the last part, because our p-value, if it is less than alpha, then we reject the null, right? But our p-value was not less than alpha, so we could not reject. So if we could not reject, so it's not significant. Only when you can reject, it's statistically significant, right? There's a significant difference.
Okay.
Okay, so yeah, probably a calculation error somewhere. Let me see 6.26. Okay. Let's try to see what's happening here. 6 square. Yeah, see, I found it. This one should be 81. Right? This is where the mistake is found out. So yeah, you should be careful when you are calculating. So 18 square over 81 plus 7 square over 72 plus 1 square over 60. 5.11, I think. Still there is a mistake. That's weird. Let's do it again. All right, let's do this one. So we got the frequencies, all of them here. We have the expected ones also, right? So 93 minus 87. So this is the first one. F1 minus E1 over E1 and this square. Then the next one is F2 minus E2 over E2 square. So F2 is 63 minus 81 square over 81. F3 minus E3 square over E3. F3 is 85 minus 72 and 72. This should be square. Last one is F4 minus E4. F4 is 59 minus the expected one is 60. Okay. 36 over 87. Let me do the intermediate wise. 18 square by 81. So this gives us 4. This gives us 36 over 87. Right, 18 square by 81, 4. Okay. 85 minus 72, 13 square divided by 72, so it gives us 2.3472. Last one 1 over 60. Okay, and is it 85, 59, 63, 93, right? 85, 63, 93, 59, yes. ABC, CBS, NBC, and then independent. Okay. I think now probably we will have this one. 4 plus 2.3472 plus 36 over 87 plus 1 over 60. 6.78. 6.78. Right. Yes. So the p-value will also change because it's 6.78, right? But it is still between 0.05 and 0.1. So it is still between 0.05 and 0.1. Is that clear to everyone? Alex and Salam or Afaf?
Yeah, I was able to follow along pretty well. That makes sense.
Yeah, it's clear.
It's good that I made the mistake because you guys know that yeah, there is a possibility of making the mistake when you are trying to solve it. So that's easy, the goodness of fit test. Okay, so let's look at the other question. Question number 2. So this is test of independence. Okay, so test of independence is actually handout number 3. So let's close the handout 2 now. Yeah, are the review sessions helpful or not?
Very.
Okay, that's great. Because yeah, even though I'm not supposed to do the homeworks, but these homeworks will be different because you guys will have different values. So I'm not directly solving the problems for you. Okay, don't just go and tell, oh, our professor solves the homework for us, but actually these are different. So let's look at this problem. Okay, so test for independence, we have to use this formula, right? So variable 1 is independent of variable 2, or alternative is they are not independent of variable 2, right? So first let's write down the let me use a black color. So what are the column names here? We have to first, they didn't even name the variable name. So we can say column variable is independent of row variable. So column variable is independent of row variable, right? Because here they just named it column variable and row variable. So what would be the alternative? Alternative is they are not independent, right? So column variable not independent of row variable. So this is the first setup. It's very straightforward. And how do you calculate the test statistic? So if you recall in our like lecture videos, so to calculate the variables, we usually use this formula, right? Row total by column total divided by the total number of n. That's how we find the expected frequencies. So in our case, these are the observed frequencies, but we need to find the expected frequencies. So let's draw their table here. So let's write A, B, C, P, Q, right? What is this? 25, 50, 20, and 40, and the other one is 40. Okay, so we have to find first let's find the column total here. So this would be 25, 25 is 50, 50, 20 is 70, 40, 40, this should be 80, right? And what about the row total? Row total would be summation along this line. So that's 25 plus 50 plus 40. So 115. So these are the row totals, and this 40, 20 plus 25 is, what is that? 85. Okay, and the total sum is 200. Now so this is the matrix, but we need to find the matrix for the expected one, right? A, B, C. So to find the expected frequency of this one, so if we use the formula, what is the formula? Row total, column total by n. So for the first matrix, let's name it E11. So row total, you guys can see it, right? Row total times column total divided by n. What is this matrix row total? Alex, what's the row total for this?
Oh, I'm sorry, I was drawing out my own. 115.
Okay, that's 115. Good. What's the column total for this matrix?
50.
50, right? So times 50. So, and what's the total n? 200, right? So what would be the expected frequency then? It's 28.75, right? So the expected is 28.75, but in reality it's actually 25, right?
See. Okay.
Okay, so let's use a different color. All right, Salam, what's the row total for this matrix? E12, maybe let's name it E12. What's the row total? Is this row, right? 115.
Yeah, 115.
What would be the column total for this one?
28.75.
No, column total is in the column. It's
okay.
70, right?
Yes, yes.
And divided by 200.
200.
So what would be the E12 then? 115.
Okay. One moment.
Yep.
15 times 70 divided 40.25. Yeah.
Right. So now who else is here? Use another color, let's say. Afaf, what's the row total for this matrix? It's in the row, right? Row total. E13.
Hello? Yeah, can you hear me?
Yes, I can hear you.
Oh, I'm sorry.
So
40?
no, the row total. Row total is this one, right?
Oh, okay, 115.
Yes. And what would be the column total for this matrix? Column,
80?
yes, times 80 Then you divide it by what? 200.
200.
Right? Good. So what's the value going to be?
Yeah, one moment.
Yep.
46.
That's great. So this would be the expected value of this matrix, right? So similarly, we can find the other one. So let me ask Alex with the green color. Alex, what's the row total for this matrix E14?
E14. Wait,
Yes.
which one is that?
The row total.
Oh, okay. So 85 times 50 divided by 200.
So you got 85 is the row total, and the column total you get from the column sum, right? So 80,
divide that product by 200
yes,
to get the expected value.
So 85 times 50. So you guys saw how we got this. 85 is the row total and column total is the 50. Divided by 200, and what's the value? 21.25. So this color 21.25. Okay. Okay, Salam. What's the other matrix? Let's use another color, purple.
Yeah.
What's the row total for this matrix E15? Or actually these are E2. Actually it should be 2, not 15, because it's 1 1 1 2 1 3. So 2 1. It was 2 1. So your one is E22. So what's
E22?
Yeah, what's the row total? Row total is the row sum, right?
Yeah.
So it's
785
okay times the column total.
times 70
Times 70 divided by
200.
good. What?
85 times 70. Yeah. Divided by 200. 29.75.
Good. So 29.75. Last one, Afaf.
Yeah.
What's the row total for this matrix? E3, the last one.
80? No.
No. The row total for the last matrix. 85, right?
80. Oh, okay. 85. Yeah.
And what's the column total? It's going to be column total is
80.
And then divided by
200.
good. So what's the value?
Okay, 1 second. $34.
Good.
Yeah.
So we got the expected values, right? So we have the observed values, we have the expected values. So why we calculated the expected values? Because main thing is we have to see the difference, because the formula is f minus ei whole square divided by ei. Okay, the expected value of that. So now you have to calculate all of this together. So the first matrix is E1 and 1. So these are the E1 ones basically, and these are the F ones basically, right? Fij, these are Eij's. So if so Fij minus Eij divided by Eij. So the first one is first you have to take the expected frequency, right? So expected was 28.75, but the observed one is what? Minus 25, right? So if I write F minus E, so this was the expected frequency, but the observed frequency is this one, divided by the sorry, this is the this should be the expected. Expected is in the bottom one. So the 25 minus 28.75 divided by 28.75, and this one has to be squared because the formula states, if we go here, fi minus ei whole square divided by ei. So let me do it clearly here, it will make more sense. That's for the no, not this part. Okay, let's actually copy this one and tools, let's take a snapshot. Okay, I'm intentionally going a little slow, but I hope that's okay with you guys. So instead of hot coffees, these are for us it's like P and Q, and those are A, B, C, right? So the categories are different in this case, but we can just ignore this part for the time being. So the first frequency is, this is 1 1 2 is 40.25, right? 1 3 then is 46, then 21.25, 29.75, and this is the 34. These are the expected frequencies, right? And in reality, what was the original one? Original one was 25, then this one was 50, this one was 115, no, this one was 40, what 115, then 25 here, 20 here, and 40 here. Okay, now you find fi minus ei over whole square over ei square. So what would be the first one then? So if minus ei over ei, this is whole square, so this is 28.75 minus 25 square it divided by the 25, I wrote it again the wrong way, it should be this one. This one actually, let me just cut and paste there. This one should be this side and that one should be at the other side. Okay, so the observed is 25 minus 28.75 square divided by the 25. What's the first one? Salam? 0.5625.
0.5625.
Okay. Alex, what's the second value?
Let me see. I'm calculating the numbers that I have from mine.
50 minus.
So 50 minus, what is that? 40.25.
Yes.
So 50 minus 40.25.
Because your observed value is 50, but your expected is 40.25, right?
So 2.36.
Okay, so the second portion is, okay, let me just label them as it is. So 50 was the expected, but is the observed, but the expected is 40.25 square by 40.25. So what's the value you got?
I think it was 2.36.
2.3618. Okay. AFAF was the third one.
Okay, so should be like 40 minus 46
Yes, square.
square, yeah,
And
divide by 2. Just give me one.
no, divided by 46.
Oh, okay. So divided by 46?
Yes. So because it's the expected frequency, you have to divide it
Oh,
with.
okay. So I should do like 40 minus 46 square divided by 46?
Yes, yes.
Okay. Okay, it's I'm sorry, something wrong with my calculator.
Yep. Okay, I got it for you. 0.782.
Oh, okay. It's 18, yeah, divided by 23. So, yeah, 0.7826.
Yep. Okay, Salam, what's the fourth one? Expected was 20, 25, and the not expected. Observed was 25, but expected is 21.25.
Yeah, 25 minus 21.25 squared divided by 21.25
Yes.
equal round to 4 decimal places.
Yes, 4 decimal, what is
Okay.
the value?
0.66118.
0.6618.
6618.
Okay. Let me
Yeah.
check. 21.25 minus 25 square. Yes, you're correct.
Yeah.
Then actually it will be 25 minus 21.25. So it doesn't matter because this one comes first and then 21.25. What's the fifth one? We have total 6 observations. So fifth one, Alex. Observed is 20. Let's use a different color. Observed is 20, 29.75 square. You divide it by what? The expected value.
Okay, so it would be 20 minus 29.75 squared. And then divided by 29.75, 3.1954.
3.1954. Okay. Last one, AFAF. What would be the last one? Last one is 40.
Yeah, I cannot see the number good. So this is like 40 and 34.
Yes, 40, and this is 34.
Oh, so 40 minus 34 square.
Yes, divided by.
Divide by 34.
Yes.
Yeah, just 1 second. So 40 minus 34 square divide by 34. Okay, 1.058.
Yes. So now we have to sum up all these values to get the chi-square value. Got it? It's a good practice that I did it in like it was done in the lectures, but now you sum all of these 4 values. So what do we get? So sum all of them. Salam. 0.5625 plus 2.
Let me add all of them.
Yes.
0.56.
0.7826 plus 0.6618 plus
0.3618. 0.7826. 0.661. or something.
Yeah, 8.6229, right?
Yeah, yes. Round to two decimal, like.
So did they ask 2 decimal? So
62.
yes. So let's see all this hard work we have put.
Excuse me, Professor, which number you added together? Can you go back to the sheet? Which number?
So I added, see all the intermediate values that I did here, right?
Yeah.
So I first I calculated the difference between them divided by
Yeah.
their expected value.
Mm-hmm.
But there will be 6 cases. So you have to sum up all 6 of them.
All 6, okay.
Right?
Okay, got it. Thank you.
5625 plus 2.36.
Yeah, 8.62.
588 plus. Yeah, 8.62 should be. Why is it showing this one? Compute the value of x square. Did we make any silly mistakes in between? 25, 50, 40, 1915. Row total, okay. Let me see if we made any mistake. Row total by column total by 200. Any small mistake will mess up everything basically. 28.75. Yes, this is the expected one, right? E1 to 115 here and 70 here. Did we copy the thing properly or not? 50, 70, 80. 50, 70, 80. Yeah, that's 200. 115 and then 70 here divided by 200, it should be 40.25. So let me check, double check everything. 40.25, that's correct too. So we checked this one, we checked this one. What about the third one? Third one is 115 and 80. 115, 80 divided by 200. 115 times 80. This is correct as well. So what about the fourth one? Fourth one is 85 times 50. Yes, divided by 200. 85 times 50 divided by 200. 21.25. This is correct as well. We didn't make any silly mistake here. So 85 and 75, the last one. 85, 70, 75 or 70? 70 divided by 200. 29.75. This also correct. And last one is this one. So this is 85, 80 and then 200. 85 times 80 divided by 200. Yeah, we got this 1, 2 actually. Right? So we got that one, and 25, 28, 50, 40.25, 40, 46, yes. 25, 21.25, 20, 29.75, 40 and 34. you know what? The mistake is here. It should be 28.75. Right? 28.75 square divided by 28.75. 0.4891. Did you guys get it?
Yes.
Alex?
Yes, yes.
Okay, good. 450 is okay. 40, 46, good. Let me see if we did make any mistake. 25 divided by, and it should be 21.25 here. Here also another mistake. So it's 21.25. All right. So let's see what this value would be. 25 minus 21.25 square divided by 21.25. 0.661. Oh, this calculation was correct. Okay, so 48,414. Okay, let's sum all of them now. 0.48414 plus 2.3618 plus 0.7826 plus 0.6618 plus 3.194 54 plus 1.0588 8.54 544. So 8.545. So 2 decimal would be 8.54. Hmm? 55. Yeah, 8.55. So round it to 2 decimal places. All right. Is that clear? But what about the degree of freedom?
Would that just be 5?
No, degree of freedom.
3 minus 3 minus
Yeah,
one.
exactly. You are correct, Salam. It's not going to be 5. Degree of freedom would
We have
be
the 3 column A, B, C.
R minus 1, C minus 1, right?
So it wouldn't be the amount of numbers that we had, it would be the amount of columns?
See, for if you look at the formulas, degree of freedom is R minus 1, C minus 1.
Okay.
So
okay.
R is the number of categories in variable 1, which is 3 categories, A, B, C, right? And C is the number of categories in variable 2. Variable 2 was P and Q. So it's only...
I just assumed it was like the total number of...
No. So for a two category, you have to use this formula.
Yeah, I understand now.
All right. So 3 categories from... if we look at our observation, there are 3 categories, A, B, C for variable 1. And for variable 2, we have 2 categories. So that's why 3 minus 1 for variable 1. For variable 2, 2 minus 1. So that would be what? 2 times 1, it's 2. 2 degree of freedom. So we know degree of freedom. We know the test statistic. Can you find p-value? So chi-squared dot dist RT. So 8.55. And Salam, what's the degree of freedom?
2.
2, okay. So press OK, 0.0139. 0.0139 should be...
P-value should be between 0.01 and 0.025.
Yes. So can we reject? Yes, we can reject because alpha is 0.05. Our p-value is smaller. So we can...
Is it smaller than the...
Yeah, so we can say they are not independent, right?
Yeah.
Let's see our null and alternative. If we can reject, so they are not independent. Yes. Okay, so it was a long problem, but it paid off. And the reason why I did it by hand is to show you guys that even I can make mistakes. Like if I overlook even a small fraction. See, only this part small mistake costed us a lot.
So I don't understand where the p-value came from. You plugged it into Excel.
Yes, Excel chi-square dot list. Of course, I'm not going to ask you p-value to calculate p-value in the our midterm too, right? But for the Mindtap problem, I can ask you what is the p-value.
Oh, okay. I see what happened. I plugged it in that same way, but I didn't get it right. But I put the degrees of freedom as 3 instead of 2.
Yes.
So that was my problem.
Okay. So it's a good practice. We did a good job for question 2. It's test of independence, and question 1 was what? Goodness of fit test, right? So let's do question number 3. Test of independence. So we have to do this thing. Do you want me to do it, or you guys can solve it yourself? This part, because it will take some long time. If you want me, I can solve it, but I probably.
Yeah, sorry, Professor. I have to go because it's almost 7 o'clock, and you told us it should be between 6 and 6:45.
Right,
It's already
right.
7 o'clock.
You can watch it later. No worries
Okay.
about that. What about
Thank
the
you so much.
other people? Salam and.
Is it solved the same way as the last problem?
Yeah, it's solved the same way as the last problem because it's the same problem, right? It's a test of independence.
Okay, I understood the last problem pretty well then, so I don't think I would need any help with that.
Okay, what about Salam? You want me to?
Same. I understand this one, and actually, I did all the homework assignment, so
Okay.
I'm fine with that.
Okay, that's great.
Yeah.
So 3 I'm not doing. For the number 4, I actually have a YouTube video there, but I can do it here. It's easy. I think in Excel. Let's do the number 4 problem here. Okay. So there are 5 categories here, right? So bank, cable, car, sale, collection. We have to find the observed frequencies. There are 200 like samples. So we can use the count function. So bank, cable. What are the other categories? Bank, cable, car, sale, and collection. Oh, no problem. So we have to use the countif function. So countif. So from A1 to how many variables are here? 201, right? So countif A1 to A201, and if they contain the word bank, so you count the frequencies. So that would give us the bank frequencies. So there are 26 frequencies of bank. So if we put the next one, 44 cable, so it automatically checks how many frequencies of cable. How many frequencies of car? So we got the frequencies here. 26, 44, 42, sale is 60, and collection is 28. So total is 200. Test statistic you have to find. So we have the frequencies, and they said 5 industries have same probabilities, so 0.2 for each, and n should be 200. So if the probability is, let's say P is, everything is 0.2, all 5 similar probabilities, and total n was 200 for all of the n's, right? So what would be the expected frequency for each? Equals to n times p, right? So expected frequencies should be 40 for all, right? But we got observed is different. So if you try to find the chi-square value, f minus e whole square divided by e, so equals to c2 minus the expected, right? You square it divided by the expected for all of them, then you find the overall chi-square value equals to sum of all 5. See, in Excel it's easy. If it's given in Excel, so chi-square value is 19. So test statistics to 3 decimal places. So just go to format cells, make it 3 decimal places.
Oh wait, can I see the formula you used for H2?
This one?
Okay. Oh, okay, I see. Thank you.
Observed frequency minus the expected frequency, right? Then you put bracket and whole square it. Then divide it by the expected frequencies.
Okay, I got it. Thank you.
Yep. Okay. So same for all the remaining 5. So what would be the p value?
0.0008.
Yeah, you got chi-square dot rt, then you found this one, right? And for this case, what's the n? It's
5.
No, it's 4, right?
4, yeah.
N minus 1, number of categories.
Yeah, 5, 4.
Minus 1, yes. 0.008, okay. 4 decimal, right? 0.008. To 4 decimal, yes. What is your conclusion? We cannot reject in this case, can we, or we can?
Reject the null and conclude that the probability is not the same.
Of course.
Yeah.
So let's check. Oh, I missed another 0. There should be another 0. Sorry. Yep. So it's pretty easy, right? And the second part is easy. You just have to drop one of the industries from here and then recalculate it. Okay. And I actually have a solution for the question 4.
Wait, how did you say you do the second part?
Second part is drop one of the industry, right? Which industry has the most complaint?
Okay,
Cell phone, right?
Yeah, so.
Then they said drop the industry with the most complaint and then recalculate everything again.
Gotcha. Okay, so you just do it the same way without that.
Same way, yeah, exactly, yeah.
So yeah, I can do it again here. It's going to be pretty straightforward. So let me just finish it. I don't like remaining incomplete here. So I'll just drop cell, delete, right? But now the frequency will change. For all of them will be 0.25. And the n will change too. Total n would be what?
Or
Total, no, I mean the total sum of the n's.
7.43.
No, I'm talking about
I'm sorry.
C12 to C15. 140, right? Total, because you dropped 60 people. So the new n would be 140, 140. And the expected would be what? This times 35, right? So observed minus expected, right? You have to square them divided by their expected value. So total sum would be I don't know why these two are coming to be same. Let's see, f minus C12, this should be C13 minus, doesn't make sense because this value, of course, observed value minus expected value, you square them, then you divide it by F12. Why C C13 minus F13. Alex, do you think it's weird because it's not going to be similar? I mean,
Yeah, I got the exact same thing, but I'm just going through the problem and still just plugging it in the same and see if it comes out correct.
yeah, I don't know what's happening with my Excel here.
Yeah, okay, so I got like the exact same thing for you as for the like what you're working on right now, the H column, and my test statistic came out right. I see. My p-value came out wrong. So I used the wrong degrees of freedom. So yeah, I mean it's coming out right for me.
For you, yeah, my Excel, I don't know what it has its mind on its own apparently.
Oh no, like I mean, like I got like the exact same thing as you, and I checked it, and it's right.
It's right, the sum.
Yep. So and then like the next two are correct, and I took the sum of all of them, and that's the correct or test statistic. I used that for the p-value and it came out correct too.
Oh, really? So let's see.
Yeah, weird.
7.43, right?
Or it asked for 4 decimal places, so 7.42. Oh, it doesn't ask for 3.
3, okay.
Yeah, so 7.42.
7.43. Yeah.
428 maybe, right? 7.4.
429.
429, yes.
Yes, 429.
And p-value,
0.0594.
so now degree of freedom would be what? 3, right? Because
Yes.
so equals to chi square dot dist 0.0594. Okay, we cannot reject here, right?
Yeah, do not reject them.
Okay. So that's straightforward. It came out right, and we solved the. This one was the most uh, intuitive way to solve it. Basically, yeah. So that's question number 4. Let's look at the question number 5. Question 5 is similar to question number 4, to be honest. So
Yeah.
let's open that. We have to find the total sum and the proportion, basically. $400, and what would be the proportion? Equals to B2 by 400. Right, so my Excel, I don't know, it's something wrong with this Excel. Oh, just okay, then you put this in that proportions here. Did they want 3 decimal? Okay, so just select this part, format cells, got it. So 0.2445 was the total 0.180.
180.
Yes.
135.
5 and
110.
thank you, Salam.
You're welcome. 105.
And fourth focus 0.063
63.
and 163, right?
Yes.
Then we have to find the difference too.
Yeah. 0.045.
0.10, right?
0.10. 0.15.
0.15, right?
Yeah. And 0.0110.
0.05
Yeah. And negative 0.017.
and
Negative 0.067.
yep, that's I think 0.10.
Yeah.
Where's the okay, so p value, and you have to find the other thing as well. So how do you find it? So it's easy as well.
Between 0.101 and 0.025.
Yes, so that's like expected. Let me see. This is the observed frequency, right?
Yeah.
And the expected frequency is 0.12, 0.10, 0.10, 0.08, 0.23. So f minus e whole square, same formula. Right, f minus e, then you square it divided by the expected. This is the f, I think. Got it, guys?
Yeah.
0.037. No, wait a minute. This is not right. No, not this one. Expected frequencies we have to calculate, right? So this is the frequencies, but the expected number.
We can use the table, right? Appendix B to find the p-value.
Which table?
Table Appendix B. Yeah, this one.
Yeah, we can use that.
Yeah. I usually use this one.
Yeah, you can use that one, but I want to do it in terms of the frequency because you need to find the chi-square value, right?
Right.
N times P. Minus divided by your expected. Now it will give you the real one. Got it, Alex?
What?
Have you got 14.99?
Let's see. I didn't plug in the sum yet for it. Let's see.
See, we have
Yep. 0.9904.
yes, and then use the Excel. Like Salam is right, you can use the table, but I prefer use Excel. It will give you even accurate.
Yeah, I did use Excel.
And how many categories here? 1, 2, 3, 4, 5, 6, 7. So six should be, yes,
And minus 1.
0.02031. Okay. So can we reject in this case? What's the alpha significance level in this case?
0.05.
So we can, right?
We can, yeah. And differ from.
That's good.
Yep. Yeah.
Okay, and then the last problem. We are almost done. This is similar to the test of independence. So it's like question number 2. So we are done with the problems. Basically, that's about it. Are there any other questions?
No, I think I'm pretty good. This really gave me a great understanding of the material.
Okay, so I will give Salam, Alex, and Afaf extra 2 credit points.
Oh, thank you.
Oh,
Yes.
fantastic. I
Alex
appreciate that.
and
Thank you,
Afaf.
Professor.
Yeah, because you guys already did the work but still attended. So I will
of
upload.
course.
Yeah, I will upload this video.
Well, thank you. But speaking of extra credit, when are you applying the extra credit points for those survey?
Okay, so that one I will probably add after maybe few days before midterm 2.
Okay, that sounds good. I just wanted to make sure that was still a thing.
Yes. Those 5 points you guys will get, and these extra 2 credit points I will add to your midterm 2 score. How about that?
Oh, that's good. Sounds good. Thank you so much.
Yes. Thank you, guys. You have a good day. Yes.
Have a good weekend.
Thank you.
You too.
Have a good break.
You too. Enjoy the break.
Enjoy your break, Alex and Professor Doza. Thank you
Yes.
so much.
You are
Thank you.
welcome, guys. Have a good day. Bye bye.
Bye bye.